All right, guys, we're going to go over the study guide that is for your radical function test on Friday. The first section, 1 through 6, is all about your properties of exponents. 1 and 4 are you're applying the same property. So we have powers on the inside raised to a power on the outside, so you're going to multiply. So it's number 1, I'm going to take 3 and multiply it by negative 4 over 3. All right. This gives me negative 12 over 3, which is equal to negative 4. So that's the new exponent for A. Then I'm going to take 3 halves and multiply that by negative 4 over 3 to get negative 12 over 6, which is negative 2. So that's my new exponent for B. So this simplifies to give me A to the negative 4 and B to the negative 2. Since both of my exponents are negative, that actually means they're both going to get dropped down to our denominator. So our final answer here is 1 over a to the 4th and b squared. And that's our final answer. Okay. Number 4, you're going to do it the same way. So I need to take 1/2 and multiply that by negative 4 to get negative 4 over 2, which is negative 2. So x now has the exponent of negative 2. Now we're going to do 3 over 2 and multiply that by negative 4, which will give me negative 12 over 2, which simplifies to negative 6. So now I have y to the negative 6. Again, both of my powers are negative, so that is going to drop them both down to the denominator. So I'll have 1 over x squared y to the 6th. Okay? If only one of them were negative, then just that 1 would have dropped. But for both 1 and 4, both of my exponents end up being negative. All right. Moving on to problems like 2 and 5, they are dealing with the same property. So what happens here is, since we are multiplying, we're going to combine like terms. And my bases that are the same, like x and x, we're actually going to add their exponents together. Okay. So here I have my constant of negative 4 times negative 5. That's going to give me a positive 20. All right. X to the negative 5 times x squared. What I'm going to do here, I'm actually going to add their exponents together. So negative 5 plus 2 gives me negative 3. So now I'm going to have x raised to the negative 3 power. And then lastly, here are my y's. So I'm going to add together 3 and negative 5. 3 plus negative 5 is the same thing as saying 3 minus 5, which is negative 2. So now I have y to the negative 2 power. I noticed that I have negative exponents here. The 20 is not. The 20 is fine, but my x and my y, they're going to get dropped down. So my 20 is alone in the numerator. And then we're going to have x cubed and y squared in our denominator. Okay. Same process happening with number 5. What you're going to do is you're going to bring your constants together first. So negative 3 times negative 5 gives me negative 15. A to the 6th times a to the negative 2. 6 plus negative 2 gives me a positive 4. So we're going to have a to the power of 4. Then b3 times b to the 4th. I'm going to say 3 plus 4 gives me 7. So b to the 7th, that's actually my answer. None of these were negative, so it's going to stay where it is. All right. The final property you need to know about is happening on 3 and 6. This is when your bases are the same and we are dividing. So we are going to subtract our exponents. All right, so I'm going to break it apart. I have 3 over 6, all right, which we know simplifies to 1/2. Then right here in the middle, x to the 4th over x to the power of 1. That's going to be the same thing as x raised to the 4 minus 1, which is x cubed. And then lastly, we're going to have y to the 5 minus negative 2, which is the same thing as saying 5 plus 2. So that is y to the 7th. Right? This simplifies. X cubed and y to the 7th are both positive, so they will be in my numerator. And 2 is the only piece in our denominator. And that'll be our answer for that one. Number 6, same thing. Take it piece by piece. First off, I'm seeing that 4 over 6 can simplify to 2 over 3. My x's, I'm going to have x raised to the 4 minus negative 2. Same thing as saying 4 plus 2. So x has a power of 6. And then here we're going to have y to the 6 minus 1, which is y to the 5th. Right? Just like before, both of my exponents are positive, so they will be in my numerator. Okay? Which a 2 is up there also. So 2, x to the 6th, and y to the 5th are all in the numerator. And then 3 is the only piece that's going to be in the denominator. So that's my final answer for that one. Okay, so section 1 through 6 is all about property of exponents. So if you were confused on any of that, make sure you review over it. Number 7 and 8 are about converting back and forth between radical and rational form. Remember we had that tree going on with the roots under the ground and the sun, okay? The sun represented the power that was always up top, and our roots are always under, and the tree represented our base. So when we rewrite, we need to make sure that my power stays up top and my root stays on the bottom. So here we go. We have the 5th root of 7m to the power of 4. So 7m represents my base. Okay, I'm going to keep it in parentheses because it was all under the radical. So in the entire 7m of my base will get the exponent. My power is 4, so it's going to stay up top. And then our denominator is my root, which is 5. Okay. Number 8, we're going the other direction. So I already have it in rational form. Now I want it in radical form. 3y is in parentheses. So both of those pieces will go under my radical. If you want to keep it in parentheses, you can. You don't have to. Okay. My root here is 4, cut on the bottom. Our power is 3. And also, since it was negative 3, this whole thing actually gets flipped underneath a fraction, so it becomes 1 over the 4th root of 3y to the power of 3. Okay, so right here, back and forth, we're going between our radical form and our rational form. All right, our third section, number 16. I don't know why I went from 8 to 16, but we did. This bottom section is all about solving our radical equations. So we're going to start right here with 16. Remember, we had 3 steps when we had to solve, okay? Step 1 was to isolate that radical, right? Step 2 was to raise both sides to the matching root power. And then your last step was to simplify and get x by itself. If you have a square root, you have a 4th step, which is to check your answers and make sure we don't have negatives being equal to the radical or underneath the radical, okay? So we have to make sure that my radical is not equal to a negative and that what is under my radical itself is not allowed to be negative, okay? Cannot happen. So let's start with 16. First off, I need to isolate. It is not by itself. I need to get rid of this 3 because having a power of 1/2 is the same thing as having a square root. So I need to divide by 3 first on both sides. This gives me x plus 15 to the power of 1/2 is equal to 9. Right? To get rid of my power here of 1/2, I need to multiply by the root, which is actually a square root. So I'm going to raise both sides to the power of 2. So we're doing 1/2 times 2, right, which cancels out. It's the same thing as squaring a square root. So we are left with x plus 15 is equal to 81. My last step is going to subtract 15 from both sides, and we get x equals to 66. Now, since this was a square root problem, right, we have that 4th step where we have to check. So when I plug 66 back into my original, so here my radicand is x plus 15. So I need to make sure that x plus 15 is bigger than or equal to 0. So when I plug 66 in here, I get 66 plus 15, which gives me 81, which is in fact bigger than 0. So 66 is our answer. All right, 17, again, a power of 1/3 is the same thing as having a cube root. So now my radical is not isolated. I have to isolate it. I'm going to do that by dividing by 2 on both sides. When I divide by 2, we're going to get x plus 4 to the power of 1/3 is equal to 5. Remember, 1/3, same thing as cube root. So to undo a cube root, I have to cube both sides. So same applies here. This will get rid of my fraction. So we have x plus 4 equals 5 cubed, which is actually 125. Subtract 4 over, and we get x is equal to 121. All right. Now, step 4 only applies for square roots. This was a cube root, so I'm actually done. It is always smart to plug it back in just to make sure that your algebra was right and it does work. I will tell you for this one, 121 is the answer. All right. Moving on, 18. Okay, I can clearly see a square root this time. And I can also see that it is not by itself. It is not isolated. I have a -2 over here. I need to move it over to the other side. I'm actually going to do that by adding it. So now I'm going to have the square root of 3x plus 6 is equal to x minus 2. Right? This one's going to be fun because when I square both sides, look what I get to do. I get to FOIL over here. So radical goes away. We have 3x plus 6 is equal to, remember, you do not distribute. There's a minus sign. You can't do that. You have to do x minus 2 times x minus 2. So that will give me x squared minus 4x plus 4. I see an x squared, so I'm going to bring everything over to it. We will end up here with x squared. -4 minus 3 gives me -7. And then 4 minus 6 gives me -2. Okay, I did something wrong. Yes, I did, because what did I do wrong? 4. Oh, you know I did. There should be a +2, which means this should be a +4. So now we actually have 4 minus 3, which is +1. All right, so I left that mistake in the video because I wanted you to see how you should react when you make a mistake. I knew I made a mistake because there was nothing to multiply to give me 7 and give me 2. I'm sorry, and add to give me 7. I messed up somewhere. Okay, we haven't done quadratic formula this whole time with this unit. We're not going to start now. So, all right, now we're on the right track. I need to factor this out. So what multiplies to give me -2, but adds to give me a +1. That's going to be a +2 and a -1. So I have 2 possible answers, okay? X might be equal to -2. X might be equal to +1, right? We do have to check because, again, it was a square root. So when we plug -2 back in, we have to check 3x plus 6. So I have to make sure 3 times -2 plus 6 is bigger than 1. I also have to make sure that 3 times 1 plus 6 is bigger than 1. Well, here I have -6 plus 6, which gives me 0, which is okay because 0 is not negative, so we're fine. 3 times 1 is 3, plus 6 equals 9. That is bigger than or equal to 0 also, right? We have one more place to check right here. X plus 2 has to be positive, so I have to check x plus 2. -2 plus 2 and 1 plus 2 has to be checked. This gives me 0, which again is okay. This one gives me 3, which is also positive. So here they actually both end up working just fine. All right, number 19. Again, my radical is not by itself, so we're going to subtract 4 from both sides. This will give me the square root of 4 minus x equals x minus 4. Squaring both sides, we will have to FOIL again over here. So I have 4 minus x equals x squared minus 8x plus 16. Move both of these pieces over. So now I have x squared, -8 plus x gives me -7. 16 minus 4 gives me +12.
All right, we need a factor, so we are going to get, let's see here, multiplies to give us 12, but adds to give us 7. We are looking for 3 and 4, both of them negative, so x minus 3, x minus 4. So x could be 3 or x could be 4. We have to check. All right, so we have to make sure right here 4 minus x stays positive. So 4 minus 3 and 4 minus 4 have to both be positive. 4 minus 3 is 1, which is positive, so we're good. 4 minus 4 is 0, which is also positive, so we're fine. We have to now check when my radical was by itself, it was equal to x minus 4. So up here, this was the 4 minus x from another radical. Now I have to check x minus 4, because that's where the radical is equal to that value. I have to make sure 3 minus 4 and 4 minus 4 are both positive. 3 minus 4 is actually negative 1, which is not. It is not greater than or equal to 0. 4 minus 4 is equal to 0, so that is fine. So because of this guy right here, I have to take 3 away. So 3 is gone. Our only answer for this one is 4. All right, going over to number 20. Radical's already by itself. We're going to square both sides. All right, this is going to get rid of my radical and give me 12 plus x equals x squared. Move everything over. So now we have x squared minus x minus 12. This is going to factor into x minus 4 and x plus 3. So our two possible answers are going to be positive 4 and negative 3. All right, we got to check them. So first I'm going to use my radicand, 12 minus x. Okay, so 12 minus x has to be greater than or equal to 0. So 12 minus 4 and 12 minus 3. Here we go. We have 8 and 9. Both are greater than 0. So far, so good. We have to also check this guy, because that's where my radical is equal to just the value. So just x has to be positive. So if I change x to 4, I'm good. If I change x to negative 3, that is not greater than or equal to 0. So negative 3 is gone. Only x equals 4 is our solution. All right, here we go. Number 21, last one. We are going to square both sides. Doing so gets rid of this radical. So now I have 15 plus 2x equals x squared. Bring everything over to the side. So we're going to have x squared minus 2x minus 15, which is going to factor into x minus 5 and x plus 3. So we have possibility of x equaling 5 or negative 3. All right, we got to check. Radicand, 15 plus 2x. Let's plug them in. 15 plus 2 times 5, and then we need 15 plus 2 times negative 3. This is going to give me 10. 10 plus 15 is 25. All right, we like that one. That's bigger than 0. Negative 6. 15 minus 6 gives me 9, which is also greater than 0. So far, so good. When the radical was by itself, it was equal to x. So we have to check this. So x by itself has to be positive. When I replace x with 5, we are greater than 0. When I replace x with a negative 3, though, we are no longer greater than 0. So negative 3 is out. We only have x equals 5. All right, so 16 through 21, this is all about solving your radicals.
All right, now we are on the back of the first page with our inequalities. We're going to follow those same 3 steps as we were doing before. So what you're going to do is you are going to isolate, then you're going to raise both sides, and then you are going to simplify. Remember, our square roots are going to have an extra step. So first things first, get this radical by itself. So I'm going to subtract 3 from both sides. So now we have the square root of 5x minus 9 is less than or equal to 4. Square both sides to get 5x minus 9 less than or equal to 16. Add my 9 over to get 25, and then divide by 5 to get x is less than or equal to 5. Right? Now remember, with our square roots, we have one more step. We have to make sure that our radicand is bigger than or equal to 0. Remember, a radicand is the number that's under the square root. So this piece right here, I have to make sure 5x minus 9 is bigger than or equal to 0. Add my 9 over, and then divide by 5. So x has to also be bigger than 9 over 5, which is approximately just below 2. So is that 1.8? Okay, so we have to be bigger than 1.8, but we have to be less than 5. Okay, so we have to be less than 5, but also bigger than 1.8. So the section we're looking for is right here in the middle. So our answer for 22 is that we have to be in between 1.8 and 5, and we are equal to both of these pieces. This is our answer. All right. 23, it's another square root for us. Our radical is not by ourselves, so we need to add the 2 over. So we will get the square root of x plus 9 is greater than or equal to 6. Square both sides to give me x plus 9 greater than or equal to 36. And then subtract 9 over. X is greater than or equal to, 27. Right, it is a square root, so my radicand of x plus 9 must also be greater than or equal to 0. Subtract that over, x must be greater than negative 9. Right, so we have negative 9, we have 27. I have to be greater than 27. I have to also be greater than 9. So where they overlap is where my x's are greater than 27. So our answer for 23 is all x's that are greater than or equal to 27. All right, 24. Let's subtract that 5. We're going to get the square root of 2x minus 5 is less than or equal to 3. Square both sides to get 2x minus 5 is less than or equal to 9. Add the 5 over. We're going to get 2x is less than or equal to 14. And then divide by 2 to get x is less than or equal to 7. Again, we have a square root, so we're going to take our radicand, which is 2x minus 5, make that bigger than or equal to 0. So 2x has to be greater than or equal to 5. X must be greater than or equal to 5 over 2. All right, 5 over 2, it's about 2.5. And then up here we have 7. So we need to be greater than the 5 over 2, but we have to also be less than 7. So the piece where they overlap is my answer. So the answer for 24 is that x is going to be greater than or equal to 5 over 2, but it's also less than or equal to 7. So it has to fit both of those. All right, last inequality. Add my 4 over. We're going to have the square root of x minus 3 is greater than or equal to 6. We're then going to square both sides to get x minus 3 is greater than or equal to 36. Lastly, add the 3 over. X is greater than or equal to 39. Radicand, pop him out. X minus 3 must be positive, so greater than or equal to 0. Add my 3 over. X must be greater than or equal to 3. So I have 3 and 39 on my number line. We have to be greater than 3. We have to also be greater than 39. So going the same direction when they're crossing over at 39, that's going to satisfy both.
remember, being greater than 3 is not always going to be greater than 39. It has to be greater than both of them. So x greater than or equal to 39 is our solution for our inequalities. All right, 26 is a word problem. Don't freak out. It tells us that the length in feet of a skid mark is left by a motorcycle traveling at r miles per hour can be approximated by the relation or the equation r equals the square root of 3s. All right, so it told us that the s was the length of our skid mark, which is in feet. And then it told us that r is how fast it was going, so that's the speed, and we're going to measure that in miles per hour. All right, it wants to know how many miles per hour was the car traveling when the brakes were applied. Okay, so we have an equation, r equals the square root of 3s. At the scene of the accident, the police measured a skid mark of 75 feet. So that's our s. So we're going to say r is equal to 3, the square root of 3 times 75, which is going to simplify to the square root of 225, which is 15. So we get r equals 15. That's our speed. So we know that the motorcycle was traveling about 15 miles per hour. All right, getting into transformations. 27 through 29, it wants you to list the transformations that are happening. 27, I actually have 4 different transformations. The negative by itself, okay, that tells you that it's a reflection over the x-axis. The 1/3 being multiplied in front of our radical, that is a vertical compression. Our x plus 8 underneath our radical is going to move it to the left 8 units. And then our plus 2 outside is going to make it move up 2 units. All right, 28 only has 3 transformations. This 4 out front, since it is bigger than 1, it is going to be a vertical stretch. The negative on the underneath our radical is actually going to be a reflection over the y-axis this time. And then x minus 3 under the radical moves it to the right 3 units. All right, 29. Even though it is a cube root, all the transformations are still going to affect it the same way. So my negative on the outside, just like on 27, is going to be a reflection over our x-axis. Our x minus 1 under the radical, again, it's opposite, so it's going to move to the right 1 unit. And then our plus 5 on the outside is going to move it up 5 units. Number 30 gives us the function and the graph, and it's asking us for the domain and range. So it told me that it is the square root of x plus 3 minus 4. It has drawn that for us. So I can see right here that my vertex is at -3 and -4. So remember, when it's asking about your domain, it's asking you about your x values. We do interval notations. Remember, you go lowest to highest. So my x value right here of -3 is actually the lowest x value on this graph because everything else is getting bigger. So we're going to start at -3, go up to positive infinity. We put a bracket around our -3 at our vertex and parenthesis around our infinity because you can't ever plot that point. Our range is referring to our y values, so that means we're looking at this y of -4. It is actually the lowest y because everything else is above it. So we're going to put a bracket around -4, go up to infinity with our parenthesis. All right, last page. This is all graphing. Some are square roots and some are cube roots. Remember, they are being treated the same way. Only thing different is if we look at our domain and range. So first things first, 31. We have a vertex here. There was no movement inside of the radical, so our x stays 0, and we went up 2 units, so my vertex is at 0, 2. It was a reflection and a stretch, so I know I'm going to draw it going down, and it's going to be stretched a little bit, so we're going to make it a little bit more steep than usual. All right. Domain, remember it's our x's, so we're looking at the x right here of 0. Everything else is getting bigger. So we're going from 0 to infinity. My range, my y value of 2, now it's my highest y because there was a reflection. So we're looking at 2 being our highest point, which means negative infinity is my lowest point. So remember, we always start at the lowest and we end at the highest. Transformations, this one had 3. The negative out front was a reflection over our x-axis. That 3 out front was a vertical stretch. And the +2 on the end is an up 2 units. All right. 32 is another square root. Under the radical, we have a +1, which meant I actually moved to the left 1. Okay, so -1 for x. And then the -2 on the outside meant that I went down 2 units. So now y is -2. So -1, -2. Here's my vertex. There was no reflection this time, so we're going up and over. Our domain, looking at this -1, everything else is above it. So we're going to start at -1 and go up to infinity. Our range here at -2, everything else is above it. So start at -2 and go up forever. All right. 33 and 34 are cube roots. So looking at 33, underneath the radical, there's no movement, so my vertex is 0. My outside the radical, I went down 4. So my only transformation here was actually only a down 4. So we're down here now. This time it's a cube root. There is no reflection, so I'm going to have that S shape going through. So I'm going to come down. I'm going to go through my vertex and finish my S. Our domain and range with cube roots is always the same. Since they don't stop, they go forever in both directions. It's all real numbers, which we write as -infinity up to +infinity. And that's true for all cube roots. All right, so 34, it's a cube root. I'm actually going to go ahead and fill that in. I know that domain and range have to be negative to +infinity, regardless of what transformations happen to it. All right, under my radical is a -3, which means I actually go to the right 3. So my vertex is 3 for the x, and then outside my radical is a +1. So we're going to go up 1 unit. So my vertex is now at 3, 1. Again, it's a cube root. There was no reflection. So we're going to come down here from the bottom. And there's my cube root function. If it was a reflection, I would actually come from over here and gone down through it that direction. All right, almost there, guys. 35 through 37, they are giving you pictures and they want you to make the function. So right here with 35, first off, I notice that it's a square root function. Okay, I'm going to find what my vertex is. My vertex, it is at a -3 and a +1. So that means under my square root, I'm going to actually have x +3 and then a +1 on the outside. Now you can kind of tell that there was a stretch going on here. So if you wanted to put a 2 or a 3 on the outside to represent a vertical stretch, you could. But I'm not going to take off if you don't. It's hard to tell exactly what that vertical stretch was. So when I give you a graph like this, I'm more looking at, do you know the transformations of up, right, left, down, and then if you notice if there's a reflection or not. So if you want to put something out here like a 3 or a 2, you can, but if you don't and leave it like this, that is right also. All right, 36. I noticed the square root again. Vertex got shifted. Looks like it is at 2 and -4. That meant it went to the right 2. So I'm going to represent that with an x -2 under the radical. And now I'm going to subtract 4 off the end of it to represent my down 4. All right, last one. Here we go, 37. I now notice that my shape has changed. So I know this is a cube root function. It is negative. It was reflected, so I'm going to have a negative. What's nice about cube roots is that negative could be on the outside or it could be on the inside. It doesn't matter because that reflection will look the same. My vertex got shifted. It looks like it is at -3 and -1. So to represent left 3, I have to do an x plus 3 under the radical. And then to represent down 1, I have to do -1 on the outside. So either one of these would be correct, because remember, reflection across the x or reflection across the y would give me that same direction change in the graph. All right, so that finishes your review for this test. If you have any questions, please come see me, and good luck on your test on Friday.